Hello friends, this video on periodic classification of elements part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 5. Using a Mendeleev periodic table, predict the formula of oxides for all these. Right, let's do that. So if you see, the first one is K, potassium. Let's see where K is. K is here, right? It's a group 1. So if you see, for group 1 it is R2O form. So K will be in this form, K2O. Very simple. Next is C. C is carbon. Carbon is here. Carbon is in group 4. Group 4 is RO2 form, right? So it will be R is C, O2 form. So this guy is CO2 gone. The next is aluminium. Where is aluminium? Aluminium is here. In the group 3, R2O3. So it will be Al2O3. Just replace R with Al. Next is Si. Si is where? Group 4. Si has O2 form, so it will be Si. Next is Ba. Let's see where the barium is. And this is this guy. Since this guy is in group 2 and it has RO form, so it will be Ba. And that's my answer. Very simple. With this Mendeleev table, you can actually find which kind of oxides or which kind of hydride will form. Besides gallium, which other elements have been discovered that were left by Mendeleev in the periodic table? These were scandium and germanium. These were the two elements that were left for which the space was left for in the Mendeleev periodic table, and they are found after the periodic table was created. What was the criteria used by Mendeleev in creating periodic table? Obviously, he used the chemical property, right? So he found the oxides and hydrides of the elements, and based on the oxides and hydrides, he created the group. And that was the group, and then ordering in the group was based on atomic mass. So this was the first criteria, this was the second criteria. Why you think noble gas are placed in a separate group? Because they are inert, they don't react, and they are different from all other. Right? They're different from all other. So they are placed in a separate group. Very simple answer. Now let's study the modern periodic table based on Moseley. So this guy, Moseley, in 1913, he showed that atomic number is a better fundamental property than atomic mass. And please note, atomic number itself was found by this guy, because till 1896, nobody knew what electron is. The atomic mass was all found by stoichiometric equations by chemical reactions. 1896, this guy Thomson found electron, and then that was the area where radioactivity was at peak, and this guy was a physicist, and he was able to find a number of electrons in a particular element by the rays it emits. Right? By rays it emits. So with that, he was able to find a number of elements, number of electrons, and that is nothing but the atomic number. So he coined this word atomic number, and he found the atomic number for all the elements, and then he observed that if you use atomic number instead of atomic mass in the periodic table as used by Moseley, it overcomes a lot of limitations. Correct? And that's what he did. Also, electronic configuration is a perfect basis for classification of element. So this is also used because there is a property that all the elements in a particular period, will have similar electronic configuration. So with that, we'll explain more when we learn when we go through the detail of this table. But just understand the electronic configuration of a particular element is the perfect basis for classification of the element. Periodic law can be stated as properties of element are periodic function of their atomic number. Let me spend some more time on the electronic configuration. For example, I have element which has electronic position of 282. That means this guy is first, second, third period, right? And this guy will tell you the group number. So this guy is second, that means it is the second group. So this is my element I am talking about. Let's suppose I have element 2, 3. So there are 2 first, second, so it will be in second period. 2 and 3, so this guy is 3, so 3 is group 30, right? So this guy is this guy. So just by electronic configuration you can actually tell the location of the element in the periodic table. We'll explain more on this, but just understand what this guy atomic number did with the Moseley periodic table, right? It corrected everything. The first thing is the position of isotope is clear now. Why? Because isotope, you see that all these elements will have same atomic number. For example, C6, right? You have 12, 13 and 14. But if you see all these have similar atomic number, since they have similar atomic number, there will be only one place for carbon, correct? And that's one. So since it is no longer based on atomic mass, there is no confusion of isotopes. The position of cobalt and nickel is clear now. You see, the cobalt and nickel is now properly arranged, right? When you talk about the atomic number, they are properly arranged. They are 27 and 28. When you talk about the atomic mass, right? So they have some confusion because the atomic mass of cobalt is more than atomic mass of nickel. If you talk about atomic mass, when you talk about atomic number, cobalt is less than nickel. So since I'm using atomic number now, right? So this issue is all resolved. Position of hydrogen is well explained because, as I told, it is done by the electronic configuration. If you see, hydrogen is atomic number is 1, electronic configuration is also 1. That means in the valence cell, the outmost valence cell, it has only 1 electron, so it is in group 1, because in this all the elements are present which has 1 electron in the outermost shell. So with this they got a position for hydrogen, because the formula for grouping is different now. It is not based on the hydrates and the oxide form, but actually it forms similar hydrates and oxide, but it is based on this electronic configuration. And also answer this question that whether it is possible to have an element of atomic number 1.5 between hydrogen and helium. We can say no. Why? Because atomic number is natural number, right? So we can't have a natural number 1.5, correct? So with that, this question, which was not answered that time, it is solved now, because atomic number is a natural number and natural number can't be 1.5. That means if I say that how many elements can be between 1 and 5, let's suppose, or 1 and 6, then I can say that there are 2, 3, 4, 5, there are 4 elements between 1 and 6, right? If we talk about atomic numbers. But if you're talking about atomic mass, you tell that 1.2 and 5.8, the atomic mass of two different elements. How many elements can be there between these elements? You don't know, because they all decimal numbers, right? So this question was also answered with this atomic number. So the only one correction, that is using atomic number instead of atomic mass, solved so many issues. So the modern periodic law says that the properties of elements are periodic function of their atomic number. Please note, it is atomic number, not atomic mass, right? So the basis of this law is that when elements are arranged in increasing order of atomic number, having same valence electron, when this occurs at the regular interval. So the outermost electron, the outermost shell, the number of electrons in the outermost shell is called valence electron. So there is it follows a periodic function. If you keep increasing if you keep arranging the elements in the increasing atomic numbers, so we'll see that this elements with the same number of valence electrons occurs in interval. For example, hydrogen, if you see, has 1, right? Then you have helium, that is 2. Then you have lithium, again that has 1, right? So the way, that's why it is. Then the helium, boron, carbon, nitrogen, oxygen. So if you see, I'll show you the table. It follows the periodicity. So let's see this modern periodic table. So elements are basis of the electronic configuration, as I told, and there are 18 vertical columns known as groups, 18 groups, and 7 horizontal rows, and they are known as periods. So you see, they are periods 1, 2, 3, 4 like this, and then they have groups. Correct? Why it's called groups? Just for the memory tip to understand this, they are called groups because this group is having same property. This group same property. So if you tell a group, because they have something same, right? Some chemical property the same. So all these groups have same property, and that's why they are called group. If you take this bunch of elements, they don't have same chemical property, and that's why they are never called group, right? So group is same chemical property, and that happens when you take the bunch in this fashion, right? And that's why they call groups. Correct? And these are called periods. And everything is based on the electronic configuration. Correct? So this guy, group 13 elements will have example, this guy is 2, 3, right? This guy aluminum is 2, 8, 3 electronic configuration. So if you see, both have 3 electrons in the valence shell, right? And they have, if you take this guy, let's suppose beryllium and magnesium. Beryllium is 2, 2, and magnesium is 2, 8, 2. Correct? So if you see, both has 2, and that's why it is group. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.